All right, these are some inorganic salts that you should take note of their colors. They're sometimes very important in the practical chemistry when you are doing your confirmation. So these are the preliminary analysis you have to something like do to far identify color of different salts and precipitates. For example, now the first compound we have, the first ion we have there is copper 2 ion. That is the color is blue. They will have a cobalt 2 ion, the hydros and cobalt 2 ion, deep blue. They will have a cobalt 2 ion, which is the hydrated salt, the one that is hydrated. It's still blue, but this one is greenish blue. It's still somehow having a blue color. They will have nickel 2 ion, then it's hydrated. Okay, the nickel 2 ion, the hydrated salt is green. Then we have ion 2 plus, ion 3 plus. Ion 2 plus is light green, while ion 3 plus is yellow or brown or yellowish brown. Now, Fe means ion. Take note of that, it's very important. They will have a manganese 2 plus. They will have the cobalt, and we have a cobalt 2 plus again. Now we CO2 plus or mercuric iodide. You can see this cobalt and the first one we did that was deep blue. That first one was anhydrous salt, but this one is non-anhydrous. That's the difference between the two. So you take note of that, very, very important. That is the color. So take note of that. Ion 2, ion 3, then manganese 2 plus. Then we have the last one, which is the chromium 3 plus, which is purple or dark green. All right, these are some other colors in addition to what we have done before. You can see it. Although the one we have identified before they are still present in this place, but written in another form, like this copper 2 carbonate. We have already looked at copper 2, copper ion 2, ion 3, and so on. The first one we have here is the salt of sodium, calcium, magnesium, aluminium, zinc, lead, ammonium. You can see they are colorless in the aqueous solution. So they are solid form, they are white. Then we have the salt of chlorides, sulfates, nitrate, carbonate, white and colorless. Then let's look at copper salts. That is called salt of copper 2. I already looked at this before. We identified this. So we have green, blue. Then copper 2 oxide is black. Then the salt of ion 2. We have already looked at ion 2. Then we're mentioning green and brown, greenish brown, and so on. You can still see them there. Then we have zinc oxide, oxide of zinc. So the oxide of zinc is yellowish. So we have a yellow when it is hot and white when it is cold. So remember we have identified that before. So we have lead 2, brown when it is hot, yellow when it is cold. That is lead 2 oxide. We have magnesium, which is white. Aluminium is still white, and potassium oxide, sodium oxide, calcium oxide is still white. You can see some of the things we use this color for. We use to identify a particular ion that might be present in the solution. You can see the colors we have identified before. You can see, for example, if we have blue color or pale green, as well as a deep green color of unknown organic salt, that is, you don't know it, you may be saying, okay, copper cation might be suspected until you confirm it. If you have green color, we'll use it for also something like make reference or test of naked cations. The brown or yellow color, remember when we're dealing with ion 3 and ion 2, you can see this one still tell us about ion. Then deep blue salt mostly represent cobalt. Remember when we did cobalt before, the first one we're doing cobalt ion. Pale pink color represent manganese. Remember we mentioned manganese before. Purple or dark green color salt represent chromium. Remember we did chromium before in the first one we did. So take note of those things, very important. All right. Also knowing the smell of some compounds is also very important in the salt analysis. We're analyzing salt, color and smell, odor, very important. Now, for example, hydrogen sulfide is a colorless and flammable gas that smells like rotten egg. For example, if you are doing salt analysis and you see a colorless flammable gas leaving your something like experiment and having a rotten egg smell, you can say, okay, it's hydrogen sulfide. Even though you have not seen the hydrogen sulfide, you tested it to see it. If you have gotten these physical properties, you just, okay, this is actually hydrogen sulfide before you now make your confirmation. So all these are just used in salt analysis to confirm some salts in the solutions. So we also have others like choking smell. Now this is just a real lab procedure, preliminary test, physical examination of salts when you are doing salt analysis. So I love this very well because this will give you some stuff you may like to know. So observation, let's look at the experiment. Smell, add a drop. Okay, let's leave the experiment because we are not doing an experiment. We are just trying to get odors and the rest, like something that smell like maybe vinegar like smell. You can see maybe this salt that you see, CH3COO minus, and we have like, okay, smell like that of a rotty egg, maybe sulfur, too. Just what we see from that hydrogen sulfide, that means sulfur, something is there. Light fluid powder, you can see it, maybe CO3 or ion. That is a dry ET test. Let's look at some colorless and odorless gas. Observation: colorless and odorless gas turn lime water milky. That is a gas that can turn lime water milky. You can see the gas involved is either carbon 2 oxide, carbon 3, and so on. You can see it may be present. See, none of them have been confirmed there. So either of these can turn lime water milky. We have some other. Look at the colorless gas with smell. Look at what I was saying just now. The next one, look at it, that's number B, colorless gas with odor. Look at this now. What I was saying just now, the first video I was doing. Colorless gas with the smell of rotten egg and turn lead acetate paper black. Look at it. Can you see that? Rotten eggs. Then we discovered that just now, and we were seeing that of hydrogen sulfide hydrated may be present. So it's either we have a sulfur 2 or hydrogen sulfide present there. It's a colorless gas with smell of a burning sulfur. You can see either sulfur 2 oxide, sulfur 3 oxide present. Colorless gas with a pungent smell. You can see this, the pungent smell. Give white flamed. Okay, we give white foam with ammonia. We mix it with ammonia, we give white foams. So what is present there? You can see either chlorine or hydrogen chloride. You can see may be present. Until you do this is just a raw test of salt analysis. And I like this very well. Colorless gas with a smell of vanilla. Remember the first one we did, CH3CO minus may be present. Then we have colored gases. Now let's go for colored gases. Now this is what we'll be okay. Reddish brown fume that turns ferrous surface solution black. You can see nitrogen oxides are present. You can see we have so many nitrogen oxides there that may be present. Then greenish yellow gas that turns the starch iodide paper blue. We have chlorine gas is involved, may be present. So it's either chlorine may be present. That means something that is greenish yellowish, that is greenish yellow, is either chlorine. Can you see that starch iodide paper blue? That one is here another test. Dark violet vapor that turns starch paper blue. Iodine, dark violet vapor that turns starch paper blue. Iodine vapor are formed. That is iodine oxide may be present. So we have so many tests here. You can see them yourself. Colorless gas with a brisk effervescence, turn line water make. We have already explained that. You can see it's just almost the same thing with what we have explained. Rotten eggs, reddish brown, ferrous salts, and so on. You can see. What we have been doing sinks. It's still just what we do. You can see all those pungent smell, that of hydrogen chloride. So what you just have to do next to ensure you note the smell, note the color. That CO2 is carbon dioxide, CO3 is carbon trioxide. See, these are what we have explained before. Most of them are what we have explained before. You can see them. You can pause this video, then you check very well. I'll just check this video. Then ensure you try your best to get as many as you can. You may not be able to get everything, but try your best to get as many as you can. In case you are doing tests, this will be very, very important for you to give your or analyze your sorts. So that's how the stuff is. So all this one are just confirmation test. Preliminary test is the one that is very important. So confirmation is how to confirm the actual thing. So we use a color, odor, and the rest for preliminary test to know what this and this may be present. So I hope you have gotten the actual stuff here. So let me just show you guys again so you see it. You can pause the video, check, pause the video, then check, pause the video, then check. Just note the color, odor, and there is smell and their color. Very, very important. You can see this one is an action. All those time lime water, milky, 10 lead acetate, paper black, ferrous surface solution black, and the rest. Also note them. It's very, very important. They are very, very important. So thank you.